All right, this lesson is on the Kelvin temperature scale. So just like how we've got distances in different units, for example, I can measure my distance that I drive to school in miles, or I can measure the distance that I drive to school in kilometers. Two totally different units, but still describing the same thing. How far away am I from school when I'm driving here? How many distances am I driving, whether that be miles or kilometers? Temperature is the same way. So temperature has a temperature scale in several different formats. The one that we're used to using in the United States is degrees Fahrenheit. So when we talk about in Arizona, it gets so hot here over the summer, it gets over 110. We're really talking about 110 degrees Fahrenheit. And if we were in Europe, they don't use degrees Fahrenheit. They use something else called degrees Celsius. So if you were in Europe, someone might say, gosh, this classroom's a little chilly. It must be like 22 degrees Celsius in here. Comfortable room temperature is 25 degrees Celsius. So 22 in Europe is actually a really big difference in temperature. Whereas for us, that might not seem like a big difference because Fahrenheit is a different scale than Celsius. Now, chemists and physicists included use a scale all on their own. They use Kelvin. So a physicist might say that a normal temperature, standard temperature, is 273.15 Kelvin. A chemist might say the same thing too. Now, we have no concept of how hot or cold that is because we don't use Kelvin very regularly. In fact, this is probably your first time hearing of it. So let's talk about why a scientist would use Kelvin over something like Celsius or Fahrenheit. So when we did our pressure versus temperature lab, we saw that our data points looked fairly linear. Now, if we measured our temperature in Celsius, what we would have found is that there's a y-intercept on the graph, and you should be writing and highlighting this with me, just to remind you, on your blank notes. But what we would have seen is that there's a y-intercept. In other words, we would have seen that when temperature is 0, Celsius that is, there is still pressure. And that was a phenomenon that was kind of questionable to scientists. If there's 0 temperature, wouldn't that indicate that there's 0 pressure? Well, if we think about what 0 Celsius means, 0 Celsius is a special temperature. It's the temperature that water freezes at. So we call 0 Celsius the freezing point of water. So if we look at water particles at 0 Celsius, what we see is that they're starting to move slowly. Now, even though they're moving slowly, they're still colliding with one another and the walls of the container, and they're still exerting pressure. As long as they're moving, they're always going to be able to collide and exert a force. Therefore, even though the temperature at 0 Celsius is 0, pressure does not equal 0. And that's because particles are still in motion. So this got scientists thinking, well, is there a temperature so cold that particles stop moving altogether? We know that when they get colder, they slow down. Could we get them to go so slow that they stop moving altogether? And we tested it, and we found that there is such a temperature where particles stop moving. And that temperature is called 0 Kelvin. So when we did our pressure versus temperature lab, if we collected our data in Kelvin, what we would have seen is that our y-intercept was 0. In other words, we would have seen that when the temperature was equal to 0, Kelvin that is, the pressure was equal to 0. And this makes sense because at 0 Kelvin, this is the absolute lowest temperature possible. We cannot get any colder than 0 Kelvin in the universe. This is the coldest temperature that one could possibly achieve. We call this absolute 0 because we cannot get any lower than 0 Kelvin. It's the absolute 0. So that being said, What does absolute zero mean besides being the coldest temperature possible to reach? At absolute zero, particles have no movement, which means no whooshies. So when we draw particle diagrams and we draw particles with no whooshies, we're saying that they're not moving. In other words, we're indicating that the temperature is 0 Kelvin. When particles are stuck in place, they never collide with one another, which means they never apply pressure, because pressure only occurs from the collisions with the particles and the walls of the container. If there's no collision, there's no pushing, there's no forces, so pressure equals 0. So you can see that for a scientist, 0 Kelvin would make a lot more sense to use because pressure is going to directly correlate to that and also be 0. So this is why scientists choose to use the Kelvin scale over the Celsius scale. So let's talk about how do we get temperature into Kelvin, because we're not always going to be given our temperature in Kelvin. There are two equations that we're going to use. If we're trying to convert Celsius to Kelvin, we're going to use this equation here on the left. I'm going to change highlighter colors though. If we're doing the opposite, if we're trying to get Kelvin to Celsius, we're going to use the equation on the right. You might really notice there's one key difference. In the equation on the left, we're adding 273.15. And in the equation on the right, we're subtracting. And that's really the only difference. So if I want to get Celsius into Kelvin, I just have to remember that I need to add 273. So for this first example, if I wanted to get 26 degrees Celsius into Kelvin, I just need to take 26 and add 273.15. Now, I don't know how to do that off the top of my head, so I'm going to do that in my calculator over here on the right. 26 plus 273, I don't know what that add is. Get out of here, add. How do I get out of that add? I don't want to send feedback. What the heck? Oh, there we go. Great, now I lost my screen. Okay, sorry. So 26 plus 273.15, what does that get us? That gets us 299.15 Kelvin. Now, in the opposite respect, if we were trying to convert Kelvin to Celsius, we just need to remember that we're subtracting 273. So I need to take 273.15, and instead of adding it to my 324, I'm going to subtract it from the 324.15. Now, I could do this by hand, I think. I kind of want to challenge myself. 5 minus 5 gets me 0. 1 minus 1 gets me 0. 4 minus 3 gets me 1. 2 minus 7, I can't do that, so I'm going to borrow. 12 minus 7 is 5. 2 minus 2 is 0, so 51.00 degrees Celsius would be my answer. So as long as we can remember when to add and subtract, we'll be great with converting. So I'm converting in this first try Celsius to Kelvin. Go ahead and pause the video. Try to attempt this on your own without my help. And when you're ready to check if you did it right, unpause the video. All right, I'm going to assume that you are ready to check your answer, that you've paused and unpaused. So if I'm converting Celsius to Kelvin, that means I am adding 273.15 to whatever my temperature is in Celsius. So 58 plus 273.15. I don't know why that just feels harder to do than subtracting. So I'm going to add it in my calculator, and I get 331.15 Kelvin. Nice. Go ahead and try the next one and pause when you're ready to check your answer. All right, I'm assuming if you're listening to this, you've paused and unpaused, you're ready to check your answer. This problem is the opposite from the last one. I'm trying to go backwards and get Kelvin into Celsius, which means I need to subtract 273 from my temperature. So I'm going to take 293 and minus the 273.15. And what do I get? 19.85. And that is in degrees Celsius, so this is my temperature in degrees Celsius. So go ahead and try the last one without my help. Pause and then unpause when you're ready to check your answer. All right, I'm assuming if you're listening to this, that means you're ready to check your answer. So this last problem, I'm converting Celsius to Kelvin, which means I need to know that I am adding 273.15. So negative 273.15 plus 273.15 is going to get me 0. Oops. Come on now. There we go. 0 for my answer, which is Kelvin. So this is absolute 0. So in Celsius, absolute 0 temperature is negative 273.15. So let's go ahead and recap before you move on to the independent practice. Celsius is not as good of a temperature scale because the y-intercept is not at 0, 0. In other words, pressure is not 0 at 0 Celsius. Kelvin is better for us to use because at 0 Kelvin, pressure is 0, so it directly relates. Now to convert, we just need to remember one key fact. Going from Celsius to Kelvin means we're adding 273. Whereas going the opposite direction from Kelvin to Celsius means that we're subtracting by 273. So this is going to be incredibly important that you know by the back of your hand that going from Celsius to Kelvin indicates adding, and going from Kelvin to Celsius in the opposite direction indicates subtracting. So what you're going to move on to next is the independent practice and getting that repetition that you need so that you know this skill like the back of your hand. Go ahead and get started.